All right, today we're diving into a virus that the World Health Organization has put on its priority list, and for good reason. It has the potential to cause a global pandemic. We're talking about the Nipah virus and the urgent race to create a vaccine against it. Picture this. It's January 2026. The news breaks, just 2 infections, but 2 is all it takes. When a virus is this deadly, just 2 cases can put an entire continent on high alert. I mean, this is the exact kind of scenario that makes global health experts sit up and pay attention. And it really brings up a massive question. How do you even begin to fight a killer that you can't predict?
So why such a massive, immediate reaction? I mean, what was it about these 2 infections that set off alarm bells pretty much everywhere? Let's get into what's going on.
Okay, so the story really kicks off in January 2026. 2 health workers in West Bengal in eastern India test positive for Nipah. Now, this isn't the first time India has seen this virus, not at all. But every single time it pops up, it's an immediate, major cause for concern for the entire global health community. Everyone's watching.
And believe me, the reaction was fast, like really fast. All across Asia, countries started ramping up health screenings at their airports, especially for flights coming from that area. We're talking Thailand, Singapore, Hong Kong, Malaysia, even neighboring Nepal. They all tightened their measures. Temperature checks, special parking spots for planes, you name it. It's a huge signal of just how seriously everyone is taking this threat.
So you might be wondering, what's all this fuss about? All this intense activity for a virus a lot of people haven't even heard of. So let's ask the big question. What is Nipah virus, and why is it so terrifying?
Well, at its core, Nipah is what's called a zoonotic virus. It's a fancy way of saying it jumps from animals to people. In this case, its natural home is in the Pteropus fruit bat. You might know them as flying foxes. And when it gets into humans, it can cause a whole range of problems, from really severe breathing trouble to, and this is the scary part, a devastating and often fatal swelling of the brain. That's called encephalitis. And here it is. This is the number that explains everything. The reason for all the panic, all the airport screenings. The case fatality rate for Nipah is just staggering. It's estimated to be between 40 and 75%. Let that sink in. That one statistic, that's why there's so much urgency and so much fear.
To really put that into perspective, think about the seasonal flu. Its fatality rate is less than 0.1%. So, yeah, Nipah is playing in a completely different league. It's right up there with Ebola, and in some outbreaks, it's been even deadlier. We're talking about a true heavyweight killer here.
And it gets worse. For the people who actually survive, the fight isn't always over. Not by a long shot. About 20%, that's 1 in 5 survivors of that brain inflammation, are left with permanent life-altering neurological problems. We're talking about things like constant seizures or major personality changes. So even survival can come at a terrible cost. Okay, so we've established it's incredibly deadly. But how does a virus that lives in fruit bats actually get to people in the first place? Let's trace how it makes that jump. You know, when you look back at Nipah's history, you see just how clever and adaptable this virus is. It's kind of terrifying. It was first spotted back in 1998 in Malaysia. There, it went from bats to pigs and then to pig farmers. But it didn't stop there. Since then, it's found all these other ways to infect us, through contaminated date palm sap in Bangladesh, through infected horses in the Philippines. And in 2018, we saw it spread frighteningly fast from person to person in hospitals in Kerala, India. What this timeline tells us is that this virus is a master of finding new ways to get to us. Let's look at the most common way it spreads in Bangladesh, which is a real hotspot for Nipah. You have these Pteropus bats, and they love the sweet sap from date palm trees. So as people are collecting this sap, the bats come along and contaminate it with their saliva or urine. Then, people drink the raw, unboiled sap, it's actually a local delicacy, and bam, they're infected. And from there, it's just a short hop to spreading to family members, to caregivers, anyone in close contact. So, when you're up against a virus this deadly, this unpredictable, you can't just sit back and wait. And the good news is, nobody is. In fact, this is where the story takes a turn toward hope. We're talking about a massive global effort, a race, really, to build a defense against Nipah. And the frontrunner in this race is a vaccine called ChAdOx1 Nipah-IVE. Now, if that first part, ChAdOx1, sounds familiar, it should. This vaccine was developed by the University of Oxford, by the very same team that gave us the Oxford AstraZeneca COVID-19 vaccine.
So these are folks who know what they're doing. The lead developer, Professor Dame Sarah Gilbert, she really summed it up perfectly. She said this work is a huge step forward against a threat that, right now, has 0 approved vaccines and 0 specific treatments. I mean, her words just highlight how incredibly important these trials are. Everything is riding on this. And this isn't just something happening in a lab somewhere. This is happening right now, as we speak. The vaccine is in phase 2 clinical trials. They kicked off in late 2025, and, this is the crucial part, they're happening in Bangladesh, one of the places that gets hit by Nipah over and over again. It's the perfect place to test if it's safe and if it can actually trigger the immune response we need, right on the front lines. And get this, in a really amazing show of planning ahead, the Serum Institute of India is already making 100,000 doses of this vaccine. They're not even waiting for final approval. They're doing it in partnership with Oxford and CEPI, the Coalition for Epidemic Preparedness Innovations. This means we're building the world's first ever emergency stockpile of a Nipah vaccine, ready to go if a big outbreak happens, even before it's officially on the market. That's thinking ahead.
But even with a fantastic vaccine candidate and this huge global effort, there's one last really unique and honestly frustrating challenge in the fight against Nipah. And this one thing is what makes the future so uncertain.
Here's the problem. The biggest challenge isn't even the science behind the vaccine. It's the virus itself. It's just so unpredictable. Unlike a disease that's always around, Nipah is sporadic. It's like a phantom. It'll flare up, cause absolute devastation, and then just disappear, sometimes for years.
And that unpredictability creates a massive paradox for scientists. To prove a vaccine really works, you usually need a big active outbreak with thousands of people. But with Nipah, those conditions almost never happen. So it leaves everyone with this incredibly tough question. How do you prove your weapon works against an enemy that only shows up by surprise? Answering that question, that's the final and maybe the hardest step in the race to stop Nipah for good.